Hi friends, in this session of probability, we study about the Bayes theorem. In 18th century, Reverend Thomas Bayes, an English Presbyterian minister, raised a question: does God really exist? To answer this question, he attempted to develop a formula to determine the probability that God does exist, based on evidence that was available to him on Earth. Later, Laplace refined Bayes' work and gave it the name Bayes theorem. Bayes theorem is useful in revising original probability estimates of known outcomes as we gain additional information about these outcomes. The prior probabilities, when changed in the light of new information, are called revised or posterior probabilities. So, in other words, we could say that a method to compute posterior probabilities is called Bayes theorem. Basically, it is an extended form of conditional probability. So look at here, probability of AI given B is equal to probability of AI intersection B over probability of B, where the probability of AI intersection B is equal to probability of AI into probability of B given AI. Here we get P of AI into P of B over AI over P of B. Or if we derive this, look at here, in other words, or we could write this formula in this way. If we derive this, P of AI given B is equal to P of AI into P of B given AI over P of A1 into P of B given A1 plus P of A2 into P of B given A2 and so on up to AN. So P of AN into P of B given AN. So here we use this formula to solve the problems related to the posterior probabilities. So first I would like to explain the derivation of this formula. So look at here. Suppose A1, A2 up to An represent n mutually exclusive and collectively exhaustive events with prior marginal probabilities P of A1, P of A2 up to P of An. Let B be an arbitrary event for which conditional probabilities P, probability of B given A1, probability of B given A2, so on up to probability of B given An are also known. Given the information that outcome B has occurred, the revised posterior probabilities of probability of AI given B are determined with the help of Bayes theorem. Using the formula, probability of AI given B is equal to probability of AI intersection B over probability of B, where the posterior probabilities of events AI given B is the conditional probability of AI given B. Here, first I would like to explain this. Since events A1, A2 and up to An are mutually exclusive, and collectively exhaustive, the events be bound the event B is bound to occur with either A1, A2 and up to An. That is B is equal to A1 intersection B union A2 intersection B union A3 intersection B and so on up to union AN intersection B, where the posterior probability of AI given B is conditional probability of AI given B. We already know that. Where the posterior probability of events AI given B is the conditional probability of AI given B in this way. Since A1 intersection B, A2 intersection B and up to N intersection B are mutually exclusive, so we get since A1 intersection B, A2 intersection B and up to N intersection B are mutually exclusive. So we get here P of B is equal to P of A1 intersection B plus P of A2 intersection B and so on up to P of AN intersection B, because we know that P of A1 intersection B is equal to P of A1 into P of B given A1 plus P of A2 intersection B is equal to similarly P of A2 into P of B given A2 and so on up to P of AN intersection B. We get here P of AN into P of B given AN. So in this way we get it, and we know that this is the summation of, if we get the summation of this all, we could write in this way: summation of I is equal to 1 up to N and P of AI or P of B given AI. So this is the summation formula we have got here. This is the P of B. So get here PV and PV. By the conditional theorem, if we apply here, so we get here probability of AI given B is equal to probability of AI intersection B over probability of B, and we get here probability of AI given B is equal to AI intersection B, probability of AI intersection B is equal to probability of AI into probability of B given AI. In the denominator P of B, we know that it is the summation of this all. So we could write in this way: summation of I is equal to 1 up to N and probability of AI and probability of B given AI. And finally we get here in this way the probability of AI given B is equal to probability of AI probability of B given AI oblique summation of this all we have to put. So we could put in this way: the probability of A1 into probability of B given A1 plus probability of A2 into probability of B given A2 and so on up to n, probability of an and probability of b given an. So this is the formula. So this is the final formula we have for the Bayes theorem. The questions related to the Bayes theorem of the posterior probability we could find through this formula. So let us see one Tito-Tech example. 3 urns contain 6 red, 4 black, 4 red, 6 black, 5 red, 5 black balls respectively. One of the urn is selected at random and a ball is drawn from it. If the ball drawn is red, find the probability that it is drawn from first urn. So we have 3 urns we have. So we know that the probability of selection of urns would be same. So we see E1 is the event. E1 is the event of selecting first urn. E2 is the event of selecting second urn, and E3 is the event of selecting third urn, and A is the event of getting a red ball. So getting a red ball from first urn is equal to probability of A over E1, A given E1, which is, we know that the number of red ball is 6 and the total number of ball red and black are 10. 6 plus 4 is 10. So 6 over 10 we have. Now getting a red ball from second urn is equal to P of A given E2. In the second urn, look at here, in the second urn there are 4 red ball and 6 black ball. The total number of balls are 10 and the red ball is 4. So 4 over 10 we have to write down here. And getting a red ball from third urn is equal to P of A given E3 is equal to, in the third urn you see here we have 5 red and 5 black balls, so we have 5 favorable outcomes and 10 total outcomes, 5 over 10. Here we get 5 over 10. And look at here, the events, the selecting of any one of the urns are same in the size and the color. So we get the same probability of selecting an urn from out of these 3. So we get the probability 1 by 3, 1 by 3, 1 by 3. So here we get finally probability of E1 selecting first on is 1 over 3. Probability of E2 is also 1 over 3, and probability of E3 is also 1 by 3, because these are the mutually exclusive, equally likely and exhaustive. So 1 by 3, 1 by 3, 1 by 3 we are getting here. Now look at here what we have to find out. If the ball drawn is red, one ball is drawn from on which is selected randomly, and we have to find the probability that it is drawn from the first turn. So the A is given to us, the ball is red, and we have to find the ball is came from first turn. So E1, it is came from E1. So E1 over A we have to find out. We have to find out probability of E1 over A. This we have to find out. So by the Bayes theorem, we have to write down here P of A over E1 into probability of E1. Okay. In denominator, we have to write down all the conditional probabilities intersection we have to write down here. So the probability of A over E1 into probability of E1 plus probability of A over E2 into probability of E2 plus probability of A over E3 into probability of E3. We have to write down here in this way. Now we put down these values here in this formula. So we get here probability of E1 over A, probability of A over E1, look at here, which is 6 over 10. So we will write here 6 over 10 into probability of E1. Probability of E1 is 1 over 3. It is 1 over 3. In denominator, the same thing we have to write here, 6 over 10 into 1 over 3 plus probability of A over E2. A given E2 is 4 over 10. So we have to write down here 4 over 10 into the probability of E2 is 1 by 3. So we have to write down here 1 by 3. And the third one, probability of A given E3. So probability of A given E3 is 5 over 10. So we have to write down here 5 over 10 into probability of E3 is 1 over 3. Now we simplify this. It is 6 over 30. In denominator, it is 6 over 30 plus 4 over 30 plus 5 over 30. In denominator, we take 30 common. It is 6 over 30. In denominator, 6 plus 4 plus 5 over 30. 30 is common in all, so we take it common. So 30 and 30 will eliminate each other. Now we see is equal to 6 over 15. 6 plus 4, 10, 5, 15. We simplify this. 3 2 times, 3 5 times. So we get here 2 over 5, which is the probability of getting a red ball which is from first on. So it is E1 over A we have got here. So in this way we could use the Bayes theorem to find out the posterior probability problems using the conditional probability methodology. Thank you.